First one is the topic for the first one is activity of hybrid and marketing updates. Joint presented by Hattori-san and Maya-san, right? And I think in this presentation you will give us some overview for the mask policy, new policy, and also the contribution to the food system and something like that, right? Okay, so please, please, thank you.
Thank you, Chairman. Good morning, everybody. My name is Mitsuru Kamiya from the Agriculture, Forestry, and Fisheries Research Center of the Ministry of Agriculture, Forestry, and Fisheries of Japan. I'd like to make a presentation on the activities of the Agriculture, Forestry, and Fisheries Research Technology Center, Africa, and the update of mapping. First, I'd like to mention that mapping stands for the research network of the Ministry of Agriculture, Forestry, and Fisheries, MAP. It is a bit confusing because mapping is the name of a research network, not the name of a ministry. So no Ministry of Research Network exists in Japan. And my presentation is composed of the 4 items shown here, 4 items. First, I'd like to talk about the general information on Africa for supporting agricultural research, including mapping. The service of Africa is composed of following 4 main items. Mapping connects about 70 location points of research institutions, including the branch of the National Research Centers. The second one is the network service system. This is the basic network service for research activities with 10,000 users. Most of the users are researchers. The third one is scientific computing system. This is a supercomputer system. The fourth one is the network library system. And this system is operating Agropedia integrated database system, as well as operating a branch office of National Diet Library and reporting information on achievement of domestic agricultural research to FAO, Food and Agriculture Organization of the United Nations. This slide shows what I explained in the last slide. Mapping also provides an international line with the Philippines to connect with the International Rice Research Institute. This line has been also utilized by the Philippine Research, Education, and Government Information Network, President of Advanced Science and Technology Institute. I will explain later again. And you can also find the connection with APAN, SciNet, and so on. This map shows that mapping connects about 70 access points of research institutes related to agriculture, forestry, and fishery, including branch offices to cover all the areas in Japan. Now, I would like to talk about the recent policy of the ministry very briefly. MAP promotes mid-range strategy. The English title is rather long, but in Japanese, we say green strategy, because in Japanese, middle means green. Sustainable food production and efficient food supply chain is indispensable to feed the growing population in the world. This strategy is established to achieve the SDGs of the United Nations. And this strategy emphasizes the importance of R&D activities for agricultural sector innovation. The ministry intends to advertise this strategy intensively for international discussion. So we have not only English version, but also French version of the brochure. This strategy would be comparative to the Farm to Fork strategy of the EU and agriculture innovation agenda of the United States. The Middle East strategy covers a wide range of matters, including food, environment, and social matters. So I attached this slide just for reference. Please read it later. And this slide is also just for reference. And as I said, that this strategy emphasizes the importance of R&D activities for agricultural sector innovation. My intention is to explain that MAPIN supports this strategy in implementing research activities. The Asia monsoon region shares many characteristics with Japan, such as high temperature and humidity, rice-based agriculture, and a high percentage of small and medium-scale farmers. From this point of view, many of the agricultural technologies developed in Japan are supposed to be in the Asia monsoon region. MAP assigned the implementation of the collaborative research project to GIRCAS. GIRCAS is a Japan International Research Center for Agricultural Sciences. GIRCAS plays a core role in international collaborative research. And GIRCAS conducts this project under the name of Green Asia. Utilizing the research network of GIRCAS, we will accelerate the application of scalable agricultural technologies to the region and contribute to the transformation of the food system in the Asia monsoon region. It contributes to achieving SDGs related to sustainable food production, food supply chain, and environmental issues. Now, I'd like to introduce briefly some examples of the research activities. The first example is GIRCAS project named Food Rights, the Weather Rice Nutrient Integrated Issue System. GIRCAS conducted a research named Food Rights in collaboration with IRI, International Rice Research Institute. This project was conducted based on ICT technology using seasonal climate prediction model and real-time weather data coupled with the crop growth model. And field validations and demonstrations in Indonesia and the Philippines have shown that Food Rights we use to determine the optimum sowing period and improve the efficiency of fertilizer application. This allows rice farmers to manage their resources and to improve farming plans. The next example is the automatic counting of plant hoppers that are economically important tests for rice in East Asia and Southeast Asia. These tests sucks the nutrition from plant body and disseminate diseases. This project developed an AI system by deep learning, and the AI system dramatically reduces the content task from, for example, 1 hour to 1 minute per survey board. Survey board is about A4 size. The next example is the forestry research by the Forestry and Forest Product Research Institute, PRI. First research covers a wide range of items closely related to our life and environment. Mapping system is utilized for data exchange between branches of FPRI for research activities in 10 access sites. Supercomputer service of Africa is utilized for the simulation of the effect of climate change, natural disaster correlation, and development of gene database of stress rates. This is the project of ocean assimilation model with the ocean states around Japan by Japan Fisheries Research and Education Agency, FRA. Output data of this project include current velocity, temperature, salinity, sea surface height, and so on. They are updated weekly, including the prediction up to 2 months cycle. This tool is useful for fisheries because the ocean states affect the behavior of fish. This project is implemented by Niigata branch of FRA. Nothing is utilized for data among 15 access sites of FRA, and the supercomputer in Tsukuba is used for data analysis. I introduced some research projects using advanced ITC technology because global research network is indispensable to promote research activities. Mapping is grateful to the support and coordination from APAN and other related organizations. Now, I would like to talk about the upgrade of the mapping link connected to the fields. Mapping has been operating mapping PhD jointly with the University of the Philippines to connect with UNIT, and also is the Department of Science and Technology of the Philippine government. This link has been also utilized by the Philippine Research, Education, and Government Information Network. This link was upgraded in January 2022 from 1 Gbps to 10 Gbps. Another update is the MOU between Arena Fund and DOS signed in November. The MOU mentioned that they would be present a global engram located in Ghana in order to connect the country to the Arena Fund. We welcome this MOU because it is good of the existing marketing PhD and contribute to highly resilient high-speed network services for science and education community. Discussion on the detailed technical matters for operation of these lines is underway among the related parties, including marketing. I would also like to talk about the agreement on the collaboration among mapping, NICT, NII, and Y. These four organizations will promote smooth and effective public exchange among the networks to contribute to Japan's research, development, and education networks. Sinji was established following this agreement. Sinji is the abbreviation of the Coalition for comparable network of Japan and international. So these are four representative for organization. And we can find Dr. Shinji Shimoto smiling for this picture. Somewhere. And I'd like to introduce another Shinji, Mr. Shinji Hotori, my boss, over there. At the conclusion of this presentation, I'd like to mention the following message. At first, sustainable food production and efficient food supply chain is indispensable to feed the growing population in the world. And MAPI promote integrated strategy to achieve these SDGs. GCAS implement the Green Asia project to build a system for international cooperation and disseminating information. Public and mapping contributes to implementing this strategy. And mapping will also continue to exchange research data of institutes in European and North American countries by cooperating with arena partners, silent, and so on. Global research networking is indispensable to promote research activities. Mapping is grateful to the support and coordination from other related organizations. Thank you very much for your attention.
Thank you very much. Thank you for the presentation. Any questions from our audio team? Here, and the question. Okay. Actually, China is also a country with a good population, and I believe we also be on the research activities for the sustainable food system. So we, although it's not my major topic, but I hope we can learn something from that just for the sustainable food system in the future. Thank you so much.
Thank you very much.
Thank you. Okay, so the topic for the second talk is about the update from the King Abdallah University of Science, and the president by Alex, and which will introduce the heritage status of the town international connection and projects, including their contribution to the GNAG, data-intensive science working group, and the strategy to improve their local and global research by enable collaboration with partners around the world. Okay.
Thank you. Good morning, good evening, or good afternoon, depending on people watching remotely. Alex Moda from House, the King Abdullah University of Science and Technology in Saudi Arabia. I'll bring you a quick brief update on our network and cyber infrastructure. House, for those who didn't know before, the university located in the shores of the Red Sea, Saudi Arabia. It's located 100 kilometers north of the city of Jeddah, which is the second largest city in the country, beside Riyadh capital. We are a campus which comprises the city with everything in it. So we have our residences, we have lots of services, and of course the campus we now holds a number of students, PhD students from more than 130 different countries. Our faculty as well. And we have a campus which is about 40 kilometers square meters in total area. And there we have a number of different research centers and program, mostly to make research in food, water, environment. We have research on preservation of greenscapes or coral greenscapes. We have research on weather prediction. And yeah, we also develop physics programs. So all these material and computer science projects we developed, we are going through some development in our infrastructure. We have the supercomputer, the largest one in the Middle East region, the second two. It was one of the top 500 when it was launched years ago, and it's soon going to be replaced by China 3, our newest supercomputer. It's going to be around 20 times faster than Second 2, and this will be announced later in this year, 2023. It's a new modern equipment. It holds the new APAN55 processors, the NVIDIA Grace Hopper superchips as well. So we hope to be very more capable of running those research projects in this infrastructure. And along with the computer, we also hold a very large network in our campus, which holds a number of different services and roles. So we hold a network provider for research. We hold a business network as well. We also hold data centers for different purposes in this our campus. We have our own internet service provider for telephony, TV services, broadband internet, and also emergency security services, commercial service providers, and also the international connection that I'm going to talk about a little bit. We have a lot of traffic, more than 1.3 petabytes each month. We have 3 international hubs in our cyber infrastructure, more than 8,000 components in the network. We have more than 3,500 homes connected with fiber to the home with 20 connections. We have a fully meshed core network with 100G connections, and international connectivity. We have 4 times 100 gigabits per second connecting to Amsterdam with 2 times 10, 2 times 100, and to Singapore also with 2 times 100. And we hold more than 4,000 Wi-Fi access points and a very large number of network ports. In terms of the international connectivity, here's a map showing the cable system that supports our connectivity to Singapore and to Amsterdam. So those are 2 commercial services from mobile and GPN data providers. And over these connections, we have our planes of services. So in those planes, we have the capacity to have failover for both sides, and also the capability to connect directly Singapore to Amsterdam, or including CAUS. The connections we can have from CAUS to Amsterdam, from CAUS to Singapore, or directly from Singapore to Amsterdam. So those 4 circuits of 100G, they work as a failover for both directions, Amsterdam and Singapore. And we run segment routing traffic engineering in those planes. We have the QoS capability as well. Yeah, so everything runs on top of those, including our peerings for all the research and education networks, and also commercial providers and cloud providers. So that's a large service we run there. We also have our own ScientMD, following the architecture principles developed by the ESNet team, which is a great approach. So we are capable of running our own data, moving data-intensive science from our campus through these 100G connections to any kind of partner institution that also can have their own science MZ. And in more detail, this science MZ holds equipment, a server, FPF with 190 gigabytes of RAM, two CPUs, and we have this 100G connection direct to this server, and we have more than 100 terabytes of capacity for now. So this is our current setup, but we are improving on that. We want to science MT as our own environment for further developments. So we want to have the supporting connections to test beds, supporting out-of-load connections, supporting people. So this will be our evolution platform for research. And everything is connected and aligned with the DNA architecture, which connects all the research education networks across the globe. So you can see that in the Middle East region, in the middle of the graph, the map, we have Jeddah on the middle, where it's close to cows. So the connections from Africa to Singapore are the only ones that are currently available in this GNA architecture, and cows is sharing this capacity with partners from agreement like the Asia Pacific Europe ring, the AER, and also with many different MNs. So we have CERT and we have Sinex from Japan. We are supporting our nets crossing the between Singapore and Amsterdam using this capacity. So this is another view of the connectivity, and this is the map of the AER. So the green lines are the cow swaps that we are sharing capacity with these partners. And currently, it's possible to see the link utilization from cows along with the other partners, like the APAN55 region. So if you go to netsage.global, you can find real live updated maps showing the link utilization. And I'm going to show you a little bit of these traffic in our circuits in a moment. We have plans to use these connections from the Asia Pacific region to reach other parts of the globe. Currently, our routing sends traffic mostly to in direction to the Europe, in North America, and other places. We have also the peering with in Singapore, but we want to leverage this capacity that's available in the Asia Pacific to reach the US and other continents. And for example, in the front back, we see that a lot of capacity available. So the utilization allows us to use this capacity as well to get to the US, when we are going to make some experiments to improve data-intensive projects using this capacity. So this is the map. The red lines will be current counts of connection from Saudi to Amsterdam to Singapore. And from Singapore, we have these options of path that we want to build layer 2 circuits to using out-of-load technology to start making data transfers to different institutions in the US, because this is our main destination for many of these projects that we run. And then there are lots of flows going to the US and North America in general, and we want to leverage these paths to make them happen. Yeah, so we are working with partners like Starlight and Cynic, have these layer 2 circuits landing in the LA, Seattle, and Chicago. And these 14 projects, like these computing demonstrations, that we did that last year, 2022. We plan to keep doing that for next year, for this year, 2023, and in the future as well. And we hope that those connections will also be supporting other projects like the before best practices that inspired by GR. This is a view of the data transfers that the house does with many different institutions, only on the area of the biogenomics and bioinformatics. So you can see that there is a lot of interaction there. This is from NetSafe, so this is a real live practical from our network to many different places in the globe. And when we look at the top talkers, we have this sample of the last 6 years of communication, and then there are a number of different institutions, mostly in the US, but also in the Asia Pacific region. We also have traffic exchange with Japanese institutions, Japanese institutions. But there you can see a list of many organizations that generate most traffic with CAL in this last year. So yeah, for the last 1 year, you can check on NetSafe. You can see the track that we changed with the institutions in the US that are in this red square. And the total amount of traffic, the total volume of traffic for the terabytes. And we are working hard to improve that because through time, we can see that many of the flows, they are not reaching gigabit speeds. And that's why, because many of the house researchers and professors and students, they are not still aware of the better ways to move data around. So we are working on science engagement fronts to let them know about tools, about procedures, about methods that they can add in their scientific workflow to make better use of this cyber infrastructure and network capacity. So we hope to see this year and in the future a higher throughput of data scientific from house. And yeah, here is another example where we can see traffic flows with Kansas University, with many different US institutions in universities, or even NASA or NPA or weather prediction research. And the average rate is not great. So we are working hard to make that much better. And we don't want our users, our scientific researchers, our staff waiting longer weeks or months to move large amounts of data. So that needs to be to accelerate the scientific outcome. And here is another example that shows the most traffic we have with different destinations from Saudi Arabia to different countries like US, South Africa, and Japan. And top sources that sends traffic back to Saudi Arabia. As a country, we have those US, Japan, South Africa, China, Hong Kong, Singapore, as we can see in message. Yeah, and in terms of flows of institutions that send traffic to CAL, we see US institutions as well as Japanese. So the first one, the largest partner that sends most traffic. And yeah, so that's why we have this, we are aiming to improve the data transfers with the US. So we hope to have a good impact to improve the scientific data transfers with the United States. And we have another view that can show data flows by many different scientific disciplines. So here we can see that we can, besides bioinformatics, all the other disciplines are generating this amount of communication from house to the rest of the world. Again, it's possible to see that North America is a great destination for exchange traffic, and then that's why we want to keep making improvements in this area. That's why we are involved and collaborating in close partnership with researchers that develop projects like the alcohol cells and under the umbrella of the GNA, the Global Network Architecture Group. In the there is a chaos node there already. And we want to improve that, allowing complete infrastructure for auto-load deployments. Auto-load is a technology that allows the network engineers from all end-rands to build layer 2 circuits from point A to point B, and have those network connected and allow the researchers to make data transfers more efficiently through this communication path with direct from the point you mentioned. And we also are interested in working with the global full testbed that we see that can be an improvement on top of the outdoor, where many institutions are working together. So you can see a list of many different NRANs there. And we expect to be enabling our own node in our IPNZ to be part of this initiative that we hope will also allow us to improve our scientific outcomes with better data transfers. Yeah, and so that's why we see that the scientific workflows need a lot of work, manual work. So automated provisioning of and also the practice engineering for across these wide area connections are important. And we also see that many of the NRANs like like Internet2 and ESNet are improving their internal networks using a lot of automated and provision ways to do it programmatically. And we think this is a better way to do things also because there is not enough manpower to handle all the work involved in building those networks and operating them in a very good quality. So we want to improve our automated provisioning for our internal network as well. And yeah, we need to also look into inside network or computing and storage infrastructure to also follow these trends and go along with all the cyber infrastructure developments to handle these data intensive projects. So our roadmap includes sharing more net flow data with the net-based projects. We want to also improve our monitoring of network performance using Sonar 5.0 internally. We already have around 30 nodes internally, and we want to have nodes available for our NRN partners to also make measurements in terms of the performance and also the AER. So you can have a broader overview in a dashboard that everyone can have a public access and check how things are going. We want to collaborate with again with the supercomputing and keep working on that. We are going to participate in Data Mover Challenge this year with supercomputing Asia. We we'll keep working to have our direct layer 2 service to the US partnership with the Starlight and Scenic Pacific Wave. And we are working to enable our own NSI domain, which is where handles and operates the optical sales dashboard. So we are going to have that in our network. And so we want to have rare router, which is a GL project led by our friend Frederick. This project is interesting for us, and we want to have the equal dashboard run in our platform as well. So this will help us to keep sharing and collaborating with all of the end brands. And hopefully that we will also bring us up to speed with moving data more efficiently to support science and education. So that's what I have.
Thank you for the presentation. Any question?
Thank you. English very much for this. Understanding when you go to the seats, but knowledge top.
In Europe, I don't have this information right now, but you have? Well, in Europe, okay, no, that's okay. Help me upgrade my material.
Thank you for your presentation. Very interesting. I have two questions. The first is more of a technical question related to your network. You were mentioning that you were running MPLS using ISIS segment routing extension. And I was just wondering if you were running also ISIS multi-topology with IPv6. So you are in SRT or SRv6, because you actually use SRv6 in Copenhagen.
I confess I have to check that back with our team, but we are capable of doing that if we are not already doing. But I really have to check.
The technical question was related to the architecture design. Are you running MPLS product square or the P, the provider edge, and the P router are distinguished?
What?
I mean, the P router and the PP router are separated. So
yes.
Also, this is a disaggregated design.
Yes, yes.
So yeah. I'm glad also that you have a much flow data that you plan to export. Not sure if you would like to test it, but we can use RF router and transform it as to ingest BGP for Skype data from a system from given by Jean for the NIMO. NIMO ingest all the flow data and then from that point detect automatically DDoS. Some BGP also start with router that could mitigate the traffic and just wash the machine. If you're interested in that, we are developing it in the and out of the organization.
Yeah, that's very interesting. Thank you. Yeah, we can try that. We have planned to deploy some software provided by the Indian University Global NOC to export anonymized flow data from our traffic to contribute message. But we can also work on this front to have this additional protection or protection in our project. That's great.
And I was really interested. I want to ask, the country became between the top in here is now below. So, my current data, the European exchange with lots of which year Down area, you're focusing on the ground, top, using the chicken and network. Like at the I was sorry. Yeah, it's just my question. I curious is you mentioned the many bio genomics exactly organization. And so for your each research area, you are consider like astronomy or feeding energy or um
It's a hard question. I have to think about this to give you a good answer. Yeah. You want to?
So it's a two parts to the question. So health research areas for this, which is energy and world. Something about around support me a little bit from next week. That was on the 2018 education providing circuits for circuit.
Because we are just a little behind the time, so maybe you can, if you have any further question, or you can around the title lunch. Yeah, so that's what please.
Thank you, Alex, and for your presentation. So you have mentioned in the presentation that you have more than 4,000 subscribers over your classes. I just want to know whether you are maintaining or managing this wireless network controller base in on-prem controller base, or whether you maintain this this and
it's local. Everything's local.
This is local.
Yes.
So it is local. Do you maintain? Do you face any complexity to maintain campus network wireless network? Answer the other issue.
We have everything by ourselves. Yeah, we looked at. Basically, we're a Cisco shop, right? So everything we are.
How many functions you are using for maintaining all those 4,000 achievements?
Yeah.
One second question that is. So yeah, you have the residence for students and teachers. Okay. So whether you are providing internet to the residents using wireless network or UTP to the home?
No, it's wired access, and internally we also have a Wi-Fi service which is currently upgraded to Wi-Fi 6, and that's available for whoever wants to have. Well, basically today each resident needs to provide their own Wi-Fi, but if they want this new service, they can ask for it, and they will be provided by us. Exactly.
As a maintainer, as you are the network maintainer for the facilitator for those your faculty and the student and the residents. What actually you prefer to give them, whether it is wire connectivity or wireless connectivity, you prefer to do both? Thank you.
Okay. Presentation next, and we can carry on for the later. Okay. Thank you so much.
Okay. Thank you. Namaste.
Yeah. So the next talk from our Europe partner, President Hilder, and the topic is joint and part of the international R&D network, and which will have the joint approach and how they intend to play their part in the future of global education.
Thank you for the introduction. So I just want to get the record straight here, especially after Alex's presentation. I'm not a network engineer. I'm not a network architect. So I feel a little bit like a fish out of the water here. But what I can do is I can give you an overview of the current state of play and GEON's role in the intercontinental connectivity provision, and outline also the approach on how we intend to play our part in the future. So I'd like to kick off with this map. It's admittedly a very Europe-centric view of the world, but my job is to give you the European perspective here. This map shows or visualizes the global reach of GEON, our connectedness, if you like, and so that the interconnections with other parts, other regions in the world are globally important players. And I like to stress that this also visualizes the community spirit in our global environment world, because this is the product, not of GEON alone, this is the product of joint efforts of the wider community. So intercontinental links coming into Europe or departing from Europe currently in aggregate total to about 9 terabits. So if we look at the traffic profile of GEON, about 25% of all the traffic that goes over the GEON network is intercontinental. So it is obviously a strategic role for GEON to ensure that these global pathways are in place. And as you know, GEON is a membership association for the European entrants. And so we have an explicit mandate from our members to play an active role in global connectivity provision, driven by the global needs of our members, their users, and obviously to make global research and education collaborations possible. So how is this map I just showed populated? GEON has a long-standing history in working together with the wider community, the global community, in delivering intercontinental activity, and there are various approaches. We either procure our own links, or we peer with global partners that bring their own connectivity into Europe. Alternatively to this single ownership model, there's also the cost share model, where we join forces with partners and we typically buy and manage this connectivity. This is the approach we adopted in the past with our Chinese partners in the context of Orient and Orient Plus. Another example is CA1, where GEON teamed up with European partners as well as partners in Asia Pacific to secure long-term high-capacity connectivity between the two regions. And the collaborative approach, as I said earlier on, also secures resilience through coordinated route planning and backup operations. So this I'd like to single out again the Asia Pacific Europe Ring, which this week has just seen yet another member, KISTI, joining. Now, last but not least, GEON has also long-standing involvement in helping develop a research and education network in other parts of the world in the context of EU-funded regional projects, such as Africa Connect in Africa, or the TAIL initiative with Asia Connect in its current iteration. And international connectivity procured within these projects have extended the global reach of GEON by over 40 countries around the world being connected. Now, what does the traffic counting, this global traffic counting look like? bar on the on the top on the slide shows the regional distribution of provision capacity, with clearly the US and Canada in the lead on about 15% Asia Pacific. And the bar at the bottom shows you the regional distribution of average global traffic. And this bottom bar gives you a flavor as to where our main talkers, top talkers are located. So over the last year, 75% of our global traffic was exchanged with North America, and about 90% with Asia Pacific. So global capacity provision obviously needs to be aligned to demand, needs to be aligned to future proving. So basically needs to be aligned also to traffic growth forecasts, specifically of big movers, big data movers, and also big science projects on the horizon, such as ITER, SKA, or other large data generating sources. And then on the basis of that, we estimate that our global traffic will increase at the rate of about 35% year on year over the next decade. So to meet these ever-growing needs, Jean will obviously continue working with the wider community to make sure that their capacities are in place to support these needs. But going forward, we are now also in a position to step up our own contributions to the global connectivity map. And as you know, the European Union, the European Commission, is our main funding partner, and the European Union has its own strategic ambitions of connecting Europe to the world. And we are also proud that we are considered a trusted partner in helping deliver on this ambition. And to do that, we are going to leverage new funding mobilized for intercontinental connectivity, and also tap into investment, paid investment plans of the European Union. So I'm going to outline these opportunities over the next couple of slides. For new funding for expanding the European footprint, so to speak, comes in the form of a new project. It's called ONE. IC stands for Intercontinental Connectivity, and ONE indicates that's the first funding phase. So we speak of phase one, hopefully there will be a two as well. But the significance for GEANT is, for the very first time, we have a dedicated project for intercontinental connectivity, and there is funding in place. So it's 15 million for the next 3 years. And this project is embedded in the GEANT's framework partnership agreement that we have in place with the European Union, with the European Commission, under Horizon Europe, which, as you know, is the main funding instrument of the European Union for research and innovation. Now, IC1 has two objectives. The first objective is to deliver long-term connectivity solutions in regions where there is an immediate demand or need for expansion. And the second objective is to develop a long-term or a longer-term perspective to a roadmap, if you like, to inform future activities and investments. So if we consider, as far as the first objective is concerned, that most of our traffic is actually being exchanged with North America and Asia Pacific, it makes sense that GEANT focuses on its immediate investment and procurement activities exactly in these two regions. So with expiring contracts, there was actually an urgency to renew connectivity into Asia Pacific So the legwork for that started before IC1 was actually kicked off. But the result is now the deployment of 100 leased line from Marseille into Singapore based on a 7-year IRU. The deployment is underway, about is soon terminated. We're looking at RFS dates at the beginning of next month. And this solution will also allow us to renew our connectivity with our Chinese partners, CSPNet. They are bringing an equivalent capacity into Singapore, where we're going to deal with them. And this will effectively then replace the current or expiring Aegean CSPNet 10 link. Now, as far as North America, the North Atlantic area is concerned, we are still at the planning stage there, but the objective is to upgrade to terabit capacity and focus on the spectrum, if possible. Market engagement is underway, a tender will follow, and everything goes according to plan. The idea is to have this in place in the first half of next year. So as I said, there is also a second element, a second objective to IC1, not just investing, but also planning, forward planning. And that includes a systematic collection and analysis of the data around international intercontinental connectivity. It will require understanding big science projects better, in the sense of where these collaborations will be located, where are the main data flows going to be. There will also be sustainability criteria that we will need to take into consideration, like contract duration, are there resilience opportunities, geopolitical issues or risks, and contract duration as well. And obviously also mapping where infrastructure exists or where new infrastructure is going to be. And the outcome of this exercise is a reference topology that indicating to us basically what is essential, what is to have, and what is out of scope. So this reference or this roadmap should then inform how to deploy our intercontinental connectivity and how to prioritize. I also want to stress here, this is not going to be a desk research exercise that Giant is going to do. This involves close cooperation and liaison with the community. In the first instance, obviously, we will try to understand from our partners where their global needs are, where the gaps are, where the priorities are, and involve obviously also the wider community in this exercise. Now, as I said earlier on, in addition to these new funding opportunities we have for intercontinental connectivity, we are also trying to harness new infrastructure, new cable infrastructure opportunities. And here, this comes in the form of the so-called EU Global Gateways Program, which is the EC's flagship strategy to invest in infrastructure across the world, across various sectors such as health, transport, education. But there is also the digital sector. So here the investment translates into investment into cable infrastructure, submarine or terrestrial cables. The interesting bit here is also the so-called Team Europe approach, where private sector investment is to be mobilized through EU grants, channeled through, and combined with loans from EU financial institutions, such as the European Investment Bank. 2 years ago, the Commission has also tentatively mapped their geographical priority areas where the European Union wants to see optimized connections in place, or as they call them also, priority data digital gateways. So the picture is as follows. So a better connection into Latin America. So this box is effectively already ticked as thanks to the deployment of the link between Latin America and Europe. And as you hopefully know, in the context of the EU-funded Bella project, ASEAN has secured anchor tenancy status there, which we're obviously very proud of. Other geographical priorities areas for the European Union for better intercontinental connection are the southern rim of the Mediterranean, the Atlantic, the North Sea and Arctic, as well as the Baltic and Black Sea. And the first of these digital gateway undertakings is actually already underway in the Mediterranean, which is in the immediate neighborhood of the European Union. It's the so-called Medusa project, which sets out to build the longest submarine cable system in the Mediterranean with various landing points across Europe and North Africa, and with a design life of 25 years. And the interesting part here for research and education networking is the fact that the European Union has made available 40 million euros to secure end-to-end international connectivity for 4 North African countries at access capacity of 200 gigabits per second. So the countries are Morocco, Tunisia, Algeria, and Egypt. Funding not just towards the web segment, but also the weakening of the terrestrial backbone from the end port in each country to the cable infrastructure. It's fair to say that this will be a game changer for connectivity provision for North Africa. David and myself, for years, have been trying to secure contracts on IIB terms in these countries, but the market conditions never allowed this. So this is now completely different forward here. I also want to stress in this context, the actual contracting party for this will not be ASEAN, it will be ASREN. ASREN is ASEAN's Arab sister organization, and the immediate beneficiaries will be the North African Emirates, the user constituencies, and obviously the European and wider user constituencies. ASEAN, however, has a seat at the Medusa table that was upon the request of the European Commission, and we are providing support to ASREN, the European Investment Bank, as well as the Commission itself, in vetting the proposed technical configurations and topology, and also ensuring that the commercial and contractual details are actually sustainable for ASREN and their earnings. And also, we like to be sitting at the table because we hope that this will lead to similar activities in other regions, such as the Arctic or the Black Sea, where we then have immediate or interest and relevance for our own members. So, in summary, going forward, ASEAN sets out to establish itself as an equitable partner in global research and education networking provision. So we want to play a more proactive role and also increase European ownership of these assets, driven by the mandate also from our main funder. We basically want to move away also from this customer model of pay as you grow, and really become a long-term investor into connectivity. Spectrum focus will be on spectrum to make also investments technology agnostic. And everything is going to be based, obviously, on a longer-term perspective. But needless to say that this is not an exercise on undertaking in isolation. This will be done in conjunction and in partnership with all of you, with the wider community, so that we can jointly shape together, continue to do so, the global research and education activities. Thank you very much.
Okay, thank you for the presentation. Yeah, I think we just have time for one question here. Do you have any question here? You want to save some time for us? Okay. I just heard about the for tender for the international university. You're working out yeah, for the degree grant was about in maybe in 2 years, and we will maybe we can carry out the further discussion about grants, the TNET, and further some evaluation, and also try to get some data with the real estate, some redundancy for the internet connection. Europe and China. Yeah, we are looking forward. Thank you. Okay.